Welcome back. In the last topic, we talked about the idea that if you want to build molecules, you need to be able to count out the right number of each atom in order to be able to build that material. So water we keep talking about, if you want to build that, you need 2 hydrogen atoms and an oxygen atom. What about something a little bit bigger? If you want to build sugar, you need 11 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. But we also talked about the idea that you simply can't do this. Atoms are far too small. Any object that you pick up has millions and billions of them. So counting out individual atoms and molecules is just not an option. You and I have to be a lot more clever about how we do this. So how do we get around this problem? We actually use a skill that we use in many other walks of life. What we do is we create a group word to count a large number of atoms or molecules, just like we do for other everyday objects in life. You and I are going to introduce a new term right now. This new term is called the mole. The mole is going to be our new group term of counting. So we might take a mole of something or half a mole of something. Where did this number, the mole, come from? It's the number of atoms that we find in 12 grams of carbon-12. So you can see here, I'm holding a handful of carbon-12. So that's 12 grams that I've got there in my hand. A mole is however many atoms I have in my hand, right there. How many atoms am I holding there? I'm holding 6.022 times 10 to the 23 atoms. That's a lot of atoms, just in one handful of carbon-12. This is our measure of a mole. This number, 6.022 times 10 to the 23, is so important it gets its own name. This is called Avogadro's number, and it's the number of something we have if we have a mole of them. Now don't get overwhelmed by this, see it for what it is. A mole is just a way of counting something. That's all it is, nothing more complicated than that. If you have a mole of something, you have 6.022 times 10 to the 23 of them. If you have half a mole, you have half that many. 10 moles, 10 times that many. Let's try and relate it to something you use a bit more in your day-to-day life. Here we are, I've got some bread rolls there. How many have I got? You might say you've got 2, but more colloquially, we say you've got a couple of rolls. A couple means 2. Right? What if I go for more? Count them up. How many rolls have I got there? You've counted, I'm sure you've found 12, but you wouldn't say 12 rolls, you'd say, I'll have a dozen rolls. There you are, a dozen. What are we talking about? We're saying you don't have 12 rolls, you have lots more rolls. If you have 6.022 times 10 to the 23 of them, you have a mole of rolls. So again, it's just a way of counting. But in particular, it's a way of counting when you have billions and billions and billions of something. Otherwise, not much point using our mole. So this number again, trying to give it scope. Just how big is Avogadro's number? How many items do I have in a mole? Here's that number in non-scientific notation. So as you can see, it's a really, really big number. Let's try and put this in perspective. Try and help you understand why perhaps you haven't run into the mole before in your day-to-day life. Picture the world for a moment. What I want you to do is think about the world, and I want you to think about all of the oceans in all of the world. The Pacific Ocean, the Indian Ocean, the Southern Ocean, the Atlantic Ocean, all of them together. Think about how much water there is there. Massive amount. It's about 1.3 billion cubic kilometers of water. If I put that into a more day-to-day measure for you, that's about 5.2 times 10 to the 21 glasses of drinking water. So it's an awful lot of water. But look at that number. That's about 100 times less than the number of atoms you hold in your hand if you hold 12 grams of carbon-12. So this number, Avogadro's number, is huge, but number of atoms that you can hold just in your hand. Let's have a look now at how we can use this mole, this new way of counting, to go from our new measure of quantity, our number of moles, into a specific count, counting the number of original atoms. So grab your calculators, grab your pens, we're going to do just a little bit of maths together. I've got a question here we're going to look at. If you have 1.75 moles of sodium atoms, remember a mole is just our new way of counting, how many individual sodium atoms do you have? What you and I are going to start doing throughout this module is we're going to start building what I'm going to refer to as a tool belt, a list of small mathematical equations that we can use to help us navigate around our new measure of quantity. It's going to look a bit like this. So we can move quite easily between a number of moles, which is the measure for us chemists, and the number of individual atoms. You'll see here on this chart that I have for you, that we can move quite seamlessly and easily from our number of moles to our number of atoms or molecules. There's also some new terminology here. When we refer to number of moles in a mathematical equation, we use the letter n. So n is the symbol we use to represent number of moles. In terms of unit, we measure mass in grams, we measure volume in litres, we measure moles in mole. So fantastic abbreviation, big time saver there, but that's what we have. So we can move from our number of moles to the number of individual atoms or molecules using this short equation here. The number of atoms will be equal to the number of moles that we have multiplied by Avogadro's number, that constant, the number of atoms that we would have if we had 1 mole. So if we try this example together now, my number of atoms will be equal to n, my number of moles, 1.75, times Avogadro's number, 6.022, times 10 to the power of 23. Pop that into your calculator, make sure you give it a go for yourself. If it's all gone to plan, you should end up with 1.05 times 10 to the 24 atoms. So you can see we've easily moved from the chemist's measure of quantity, the number of moles up here, 1.75 moles, to a more everyday measure. We've now counted out the individual number of atoms. That's the first major skill I have for us when it comes to working with our mole concept. We're slowly going to introduce some more topic by topic as we go. But for now, really important topic for today. What have we done? We've introduced the chemist's way of counting. We don't count by the gram, by the mil, we count by the mole. What does it mean if you have a mole? You have 6.022 times 10 to the 23 of them. You have Avogadro's number of them. If you have 2 moles, 2 times Avogadro's number. Half a mole, half of that number. Give yourself some time, let this topic sink in, make sure you're ready. In the next topic, we'll start trying to relate the mole to more everyday measures, things like mass.